can everyone, if you maybe, yeah, you can see my screen? Okay, cool. Fantastic. So, okay, let's get started. So here I've got a Google Collaboratory notebook. And if you don't know that yet, Google has an environment called Google Collaboratory, and you can upload Jupyter notebooks. And they're extremely handy because you don't have to set up your own Python environment. It's already set up for you. And that makes life a lot easier if you want to do your programming, but you don't want to necessarily have it on your computer. And I said it, I think, last week as well. Whenever I go to cafes and so on, and I want to run some resource-heavy simulations, I run it on Google Colab because it runs on their servers and doesn't drain my laptop battery within 30 minutes. And so it's actually really quite useful to have. All right. And I already did a little bit here. I started, and the first thing we do is we want to install the yfinance package, because yfinance is a package that effectively gets data from Yahoo Finance, and you can get effectively free market data, which is great. And this is what we want to use because a lot of people just want to get their feet wet a little bit and they don't want to spend a lot of money on anything. So whatever I show you today, you can do this completely for free. You don't need any proprietary data or software. So if you're familiar with Python, normally when we install packages in Python, we use a program called pip. We go pip install, and in this case, we go pip install yfinance, and that actually installs the yfinance package on the Google server without us doing anything. Now, for me, I still need to connect and initialize. And then you can see here, there's some debug messages, and it's installing yfinance. And then after a few seconds, it says successfully installed yfinance. Okay, and once this is done, then I've got a few things here that I also import, and they're really standard Python packages: yfinance, numpy, pandas, datetime, and matplotlib. And that's really it. And that's enough for us to run a backtest. Okay, so before we start running a backtest, we first need some market data. And the way you install them is just really simple. So for today, I just use the S&P 500 ETF to run a backtest on it. So today is going to be a one asset backtest. We're not going to go into multiple assets, but I can show you a little bit how to do this. It's not that hard. All right. So YF. So we go YF to download. And then we just put a ticker symbol in SPY. Now, there's a few things that you can do, options. You can, for example, specify a start time. So you could do something like this: start 2001, 1st of January. You can also specify an end time. You can even specify the data interval you want, because you get, for the last week of your data, you get 1 minute data as well. So you can't get 1 minute data from Yahoo for a long period. But if you want to do some work on 1 minute data, you can actually specify by, if you go interval equals 1M, and then make the start about a week ago, you can actually get 1 minute data as well, which is sometimes quite handy. But today we stick with the SPY and we just download daily data. So if I run this, it'll just go boom, and then it says completed. Now, this is probably actually not ideal just to do this, but I'll do it anyway. So if we look into the SPY data here, you can see it starts from 1993 all the way to 2021, 24th, so which was yesterday. And we get open, high, low, close, and adjusted close and volume data. So there's a big data set here that goes all the way backwards. And that's pretty handy. Now, today, I just want to use adjusted data. So we run a relatively simple backtest because it's more about the backtesting process. And so I don't want to get too much into it. So what I'll do is I actually say something else here. I just call this a DF as a data frame, run it again, and then I say SPY equals DF and adjusted close. So if you're not familiar with pandas data frames, just just familiarize yourself a little bit. So adjusted close is just one of the columns. And so if we go and do the SPY now, we basically just get the dates and one column. So it's a bit simpler to handle. Okay, and then we are ready to jump into backtest. Actually, before we do this, I just want to do one more thing. I just want to plot the SPY data. So I just go spy.plot. And you can see here, this goes from 1993 all the way to now. It's a pretty big data set, which is cool because you get it all for free. All right, now, so today I want to run a backtest with what I call the hello world of trading strategies. Is a moving average crossover. But actually, the moving average crossover is an interesting one. It's kind of simple, but when you implement it in a backtest, it has a little bit of a complexity to it, which you will see in a moment. So I think it's a good one to show you as an example and give you a little bit of detail on how I produce backtests. But obviously, you can run the same structure of backtest for anything you like. Now, this is only one specific structure of backtest, and it's probably the easiest to do. So there's a few others. And there is some particular one that I use a lot, which is a vectorized backtest, which runs about 10 to 50 times as fast as this. But because it's a lot more formulaic, it's a lot more complex. And I don't want to, specifically for the people who get started on this, overburden with complex programming and perhaps some sort of mathematics. So I leave it with a simple backtest, and maybe sometime in the future, we can go a little bit more into detail how to do complex ones. All right, so for moving average crossover strategy, we also need to have some moving averages, namely 2. So I call this, let's say, MA1. And then what we do is we go spy.rolling, and then we specify a rolling window. And then for the average, we just say mean. So what this does is basically it creates a window in the data, and then it moves that window along, it rolls it along the data. And for each of those windows, it calculates an average. And so this is basically a moving average. And we need 2 of them. So let's just do another one with 200 and do this. And then what we do is we want to plot them in the chart as well, so we get a sense of what this looks like. Oops. So just let me fix this, and ma2.plot. So if you have any questions while I'm going along, please ask. Sometimes I might be a bit faster than you would like it, so you can get some clarification. So this is a little bit hard to see here, I suppose, but you can see there's actually now 3 lines. There's the blue line, which is the underlying data, and there's a green line, which is the slow moving average, and there's a blue line, which is the fast moving average. And so so basically, if we drill into those data, we will see that sometimes those lines cross over, and they usually cross over when they usually cross over when we have a change in the momentum or a change in the slope. So when we go from bullish to bearish, we get a crossover of these. Now, that is a little bit hard to see here, but I hope it makes sense to you. We could probably expand that window a little bit. Oh yeah, that's better. So for example, here, when you see we're in a bear market, the green line is above the orange line. And then when we get back into bull market again, but you can see here, the lines cross over. And as they cross over, we go back into the bull market. And so this is true here as well. Again, the green line is below the orange line. And then here at the tipping point, they obviously cross over, and then we go into the bear market. Now this crossover, because it's a moving window, always has a little bit of a lag. And you can perhaps see this a little bit here. So this crossover usually happens a little bit after we actually reach the tipping point. And this is just the behavior of moving averages. There's not much we can do. And this is just normal when we use some sort of technical indicators. We will always get this lag in the tipping point, and any strategy that works with momentum or any of those slopes will have this property. So we can't do anything about it. It would be nice, but unfortunately, that's not possible. All right, now let's jump straight into the backtest. Okay, so first thing, or the first element that we need in a backtest is a loop that runs through all our time steps. So what I usually create first is this loop that then steps through time and basically provides us with the price data and also with our trading signals. And so the way to do this is just Python for for I in range, length, and then I just go SPY. And then what I can do is, for example, I can plot all the dates. So I go SPY.index. So index basically gives us all the date at the index I. And so if I print this out, I just run through a loop and just print dates. So if I do this here, I get all the dates. And I could also say something like SPY. And then ilog basically gives us the location of that of the value in that inside that data frame. So I go spy.ilog.I. I can then see the prices as well. So you see this goes from 1995 on and on and on and increases. Okay, so the reason why I'm not using the date directly is simply because sometimes we also want the date of the previous day, not just of day to day. And so if we need that, it's better if we work with an index rather than the actual date. So that's why I'm using I and not the date index in and of itself. Okay, so once we have done this, what we can do is we can define the conditions for our entries and exits. So at some point, we want to enter a trade, and another point, we want to exit a trade and enter a new trade. And in the case of a moving average crossover, what happens is we exit one trade and enter a new one. So we have, for example, a long trade. And once we go and we cross over, we might exit the long trade and enter straight into a short trade. Okay. So what we need is to define a conditional statement to do this. And one of the things that we need to do here is we basically need to say, well, if at the current time, for example, one moving average is above the other, moving average 1 is above the moving average 2, then in the previous time step, we need the moving average 1 below the moving average 2. If not, then if we only say, oh, one moving average is above the other, then this condition gets triggered all the way up that slope here. So we get triggered and triggered and triggered and triggered, and it's not just one trade, but we do many trades. So what we need to do is we need to specify the fact that we have actually a trade here at this crossover, but not a trade in any other given time. And the way to do this is just simply if, let's say, MA1 is larger than, MA1.ilog I is larger than MA2.ilog I. And this is really important, MA1.ilog of I minus 1 is less than MA2.ilog of I minus 1. Okay, and then we could, for example, say print enter long trade, right? So if our short-term moving average is above our long-term moving average, and the time step before it was the reverse, we have a cross, and then we enter a long trade. And we do the same in reverse. This time we use elif. So if it goes the other way around, we have a short trade, enter short. All right, so if we run this, you can see we go enter long, enter short, enter long, enter short. So we actually got all these crosses. One of the things we could also do is, for example, we could do something like spy.index of I. That just gives us the date at which we enter those trades. And all right. So see, now we have this, and we can see here the dates are progressively getting longer. Sometimes we have quite long times of holding, you know, sometimes the trades are a bit shorter. In this case, it's like 2 days. Here it's 5 days. And here it's like 7 days and so on. Okay. Now, okay, we've already produced the trading signals, but obviously this is not really enough. We need to make sure that we are recording the prices of which we entered and then calculate the profits for each trade. So how do we do this? Well, first of all, we need to say something like the entry price equals I.ilog of I. So we record the entry price, and we do the same here. Okay, so now we know the entry price. And then what's also interesting in the moving average crossover is that whenever we enter a long trade, we exit a short trade at the same time. So when we exit a trade, this is when we calculate the profit and loss of this particular trade. And so how do we do this? We say P&L equals. And so, you know, you probably know there's several ways of calculating profits and losses. You can calculate dollar values, or you can calculate percentage changes. And I want to show you dollar values first for very specific reasons. So I start really simply of just calculating the dollar profit that we make for this particular trade. So I say for the long trade, for example, I just say spy.ilog I minus entry. So for those of you who are programmers, you probably realize I keep it super simple. I don't use any classes or anything. I just want to make it really accessible for people who haven't seen this before. And for those who are new to programming and new to this stuff, they probably find it still quite challenging. Just so you understand that. So actually, we're entering a long trade here. And so when we're entering a long trade, what it means is we exit a short trade. So when we exit a long trade, to calculate the profit is basically calculating the exit price minus the entry price, right? Because, you know, let's say we enter at 100 and we exit at $105. Then we calculate 105, the exit price minus the entry price. So we make $5. Now, in fact, since this is a short trade, we need to reverse this. We need to go entry minus exit. And the same in reverse is true for down here, where we enter a short trade and exit a long trade. So we need to do this minus entry. Okay, now there is one more problem with this. And and what happens is when we run this now, we will get an error. Why? Because when it jumps into this for the first time, it actually doesn't have an entry price to calculate here. So we need to first define an entry price. And what we do is we call it entry equals none. So there's, we just say there is an entry price, but it's not really in existence yet. So there's still more people coming in. And then what we need to do is we just go if entry. So only if an entry price exists, then we calculate the P&L. And the same here. Now, in Python, the value of none for a variable is just as good as false. So it takes the same place as false. So if we say if entry, it basically means if entry equals something. And if it's not, if it's none, then we can just do this. So if entry is basically good enough. And then once we go through, and this is still none for the first trade that we put on, we actually pass this line and then we go to the next line here. Okay, and then we can, for example, take this, put it here, and then just say, you know, print our P&L. And we just copy and paste this line in here. And we get rid of it there and there. Okay, and then so we go short. And then we can run it. And we can see here, we actually get our P&L values from this. So far, so good. Clearly, if we have this and we would then sit down and we could, of course, take a copy and paste, put it in a Excel spreadsheet and run it through there. But we're Python programmers and we don't like Excel spreadsheets. I hope I don't offend anyone. But we can do much better than this, clearly. So what we're going to do is we create a list called P&Ls. And we collect the P&Ls here. P&Ls.append P&L, pretty simple. Okay, and so we're getting our P&Ls. Now, one thing I need to mention is we need to be really careful when we write these backtests of the order that we do things. So if we put this entry price above this one, then there would be a problem. Why? Because the entry is then exactly the same as this. And so if we calculate the P&L, then they would always come out 0. So we need to make sure we first exit our trade and calculate the P&L of our exited trade before we update the entry price. If we don't do it in the right order, then we just get zeros. And that's obviously not very helpful. So a lot of people, you know, when you sort of don't think about it and you're a little bit slack and you run this and then you just get zeros, you go, why is that? Why is that? It's just simply because the order wasn't correct. And so it's really important to do this. So let's just run this. In fact, what I'm going to do is get rid of these lines so we don't carry them along, and run it again. And now that we have this, we can actually look at what we got. So I do P&L.plot, P&Ls. And we can see here, this is a chart just of the P&L values. And as you would expect, they increase over time because we looked at the dollar P&L. So as the price of the SPY gets higher, obviously the dollar P&L will increase. So we get more volatility in our underlying prices. But that is clearly not very interesting. So what we want is the cumulative value of the dollar P&Ls. So we use the cumulative sum function, np.cumulative_sum, and we run it again. And you can see here, so our strategy goes and then makes some money, and then it does a massive, massive drop. Now, most likely, who can guess when this drop happened? That's April 2021. April 2020, the COVID crash, right? Now, this is all good and well, but this chart, you know, like if you have ever used MetaTrader or MT4, you see these charts where you just get the number of trades at the bottom, and it's not fantastic because you don't really know. It just doesn't look very good. So what I usually like to do is I used to also like to record the dates for those trades. And so I get another list. And then whenever a trade happens, I go dates.append SPY dot index of I. And so I know when that trade occurred. So let's do this here and run it again. And then what we can do here is we can just go dates. And now you can see we have the dates at the bottom of our chart. How cool is that? So that's already a big step forward. And we can see, hey, this strategy isn't actually too bad, at least up to a point. But because it's dollar values, it doesn't really mean very much, because what it means is we're just trading one single stock each time, and we hope that this one single stock appreciates. But what normally happens is we have a specific amount of money, for example, I don't know, $1,000, and then we go long or short in that one particular stock with that specific dollar value that we have. And so the way to account for that is just to use percentage returns. So the next thing we look at is how to calculate percentage returns. And that's really simple. We just put brackets around our P&L value and then divide it by the entry price. And so we do this here as well. We put brackets around our P&L value and then divide it by the entry price. And so now what it means is we get the change of the dollar value divided by the entry price of the dollar value, which basically gives us a fraction or a percentage. And so this will give us a much, much better, clearer picture of what's actually going on. So we rerun this again. And now you can see this is much better, because now we don't see this big drop at the end anymore. It's still a big drop, but it's nowhere near as bad as it was before. So we're actually accounting for the fact that we're using the same amount of dollars underneath, and then we're always adding to this. Now, you will notice here that I use the cumulative sum for percentage values. And what that means is that when we use percentages with a cumulative sum, whenever we made a trade and we, let's say, add something to our money that we have, let's say we made 1% on that trade, we take out this 1% and start again with the same dollar value. Whenever we do this, we have another trade, we take out that 1%, or let's say we're losing 1%. When our losing trade is closed, we need to put this 1% back. So we need to add some money to our portfolio. So we're basically always working with a constant amount of dollars for each trade. Now, again, this is not normally a very realistic way unless you're actually running your pension or your pensioner and you're just throwing out money from your winnings. But normally you actually want to reinvest the profits you made for every trade. How do we do this? We're actually using the cumulative product. So this is just simply cumulative product. Now, one thing to remember here is, because those P&Ls are percentages and they're really small numbers, and if you multiply numbers below 1, 0 point something with 0 point something, they will very quickly go to 0. What we actually need to do is we need to add 1 to them. And because this P&Ls here I created as a list, we need to turn this into an array, because in NumPy arrays, we can just simply add a simplex, a number 1, to each one of those numbers here in the array. And then with this cumulative product 1 plus array, we can actually produce the cumulative sum of this. And this is what you see here. This is the cumulative P&L. And when you look at this, when you actually trade in cumulative P&Ls in general, you will see that if they start accumulating, you get actually a geometric series, and the volatility increases the more money you make. So you can see here at the end, this big drop, we're actually losing a lot. We're losing effectively 300% or close to 300% at the end. But this is still, when you run this as a cumulative product, and you reinvest your profits, even with this big drop, you still come out better at the end than you would if you had run this just simply as a sum and always taken money out or putting money back in. So it really depends how good your strategy is, but generally what you want to do is obviously reinvest your profits. Now, there's a lot of talk also about when you make some money on a trade, you can take out a small or a fraction of that money to basically reduce the volatility of your profits. So there's various mathematical models of how much money you would take out after every trade in order to keep your P&L curve stable. And it's a lot to do because volatility increases with the square root of time. So there's a few square root laws in the way you would take out your money to get a more stable profit curve. But that again goes a bit too much into the mathematics of things. And today we talk about backtests, so I don't want to go any deeper into this. All right, now, so this is all pretty cool, but oftentimes we don't, when we run this, for example, and say we have a trade from here to here. Let me just do this a little bit better. So we have these trades here, but we don't necessarily know what happens in between. So we could, for example, in between those two trades, we could have a massive drawdown, like all the way to here, and then come back. And so even though this looks like our profits are going up continuously, we actually might end up with a huge drawdown or a huge profit and then a loss. And so we don't really know what's going on in the middle. And you call this series here the realized P&L. And one of the things that we really need to do is also create a series for what we call the unrealized P&L. It's basically the day-to-day profit and loss. And this is what I'm going to show you next. And when we have the unrealized P&L, we can also calculate other metrics, for example, the Sharpe ratio. We cannot calculate the Sharpe ratio of a strategy or the risk-adjusted return just from the realized P&Ls. So we really should introduce this unrealized P&L in our backtest. Now, one thing you can do with realized P&L, which you can't do with unrealized P&Ls, is, for example, to calculate your profits per trade. So if you want to know what your profit per trade is, you really need the realized P&L. So it's actually good to have both. Okay, so how do we do this? Okay, first of all, what we need to do is we need to start a variable called in pos. It means that we're in a position, and this position could be either 1, -1, or 0 for long, short, or not in a position. And as soon as we enter a new trade, so for example, if we go long here, we say impos equals 1. Here we go short, we say impos equals -1. Okay. And now what we need to do up here is, and this is really important, again, where we're going to do this calculation, we need to calculate our daily profit and loss from the strategy. And so I call this, and so this is the unrealized profit and loss. And so the way we do this is just simply we go spy.ilog of I. And so there's sometimes more efficient programming ways of doing things, but I show you the most obvious because I don't want to confuse people too much by making the code too terse. ilog of I -1. So this is effectively the dollar value from day to day. And what we then need to do is we multiply this by in pos. And so I go back to my dollar values. First of all, I just want to show you, I show you in a second why. So this is how we calculate the unrealized P&L. And so when we multiply this by in pos, then we will basically calculate, for the long case, we calculate exit minus entry. And for the short case, those signs are reversed. So we calculate entry minus exit. So this is a trick to distinguish between the long and the short case. And then what we want to do is we want to save this in a in a list. So I call this unrealized dot append, and then I go unr, and then I need to also create a list here, unrealized list. And then I also want to get the dates because, you know, we want to make sure that we can draw it over the other chart. And so I call this unrealized dt is a list as well. And so what I do is I say unrealized dot dt dot append, and then I go spy dot index of I. Okay, so now we've got our unrealized calculation as well, and I just need to run it. And so if there may be some small errors here and there, I apologize. I do this live programming while I'm talking and running a meetup. So if I'm not perfect, so sometimes there could be some issues. Obviously, the code ran well. So let's see if it actually does what we want. Now, because we're working with dollar values again, we have to change this to a cumulative sum. And then I'll do this as well here, plt.plot. And then I do unrealized dt, this is our dates. And then np.cumulative sum, unrealized. And so hopefully this will plot the unrealized and the realized charts on top of each other. And voila, there we go. So this is basically the unrealized and realized charts right on top of each other. And you can see here where the trades are. And you can also see that this strategy has some massive overshoots. For example, here, it actually makes a lot of money first before it then crashes. Okay. So this gives us some really interesting insights into the strategy as well. And then you see here at the end, we're basically missing the last trade because we didn't really have an exit point right at the end. So you can see even after this big loss, our strategy comes back and actually reaches a higher high than we had before, which is also quite nice to see. So it's not just a complete disastrous, devastating loss. Okay, so what I want to do now is run this again, but do it for percentage changes. And we get some really interesting insights here. So in order to do this, I need to divide it by the starting price again, or by the entry price. So this is what I do here, divided by entry. And here as well, divided by entry. Okay, and I run this. And then we see there's a discrepancy suddenly between those two. And we go, well, that's a bit strange. Why is that possibly happening? And the reason why this is happening is because initially, when we calculate the percentage changes for here, for our unrealized, we're actually changing the base of the percentage change every time. So as our price changes, our percentage base changes, whereas for our realized P&L, the starting price stays the same, and then we get one big change, okay? So that actually means that those two charts will look slightly different. So this is just important to remember when you use percentage values and you see this discrepancy between realized and unrealized. This is not necessarily an error, and you can double check whether you did the right thing or not by just looking at the dollar values, the pure dollar values. They should always match up, whereas this should not necessarily match up. It's just simple maths. If you actually sit there with a paper and a pen, you can easily calculate it and see that this is true. All right, now that we've produced this, we go, okay, how good is my strategy? What can I, what can I say about my strategy? And one of the best metrics to use to see whether a strategy is nice is the Sharpe ratio. And so I show you next how to calculate the Sharpe ratio. And that's actually pretty easy. We just go, we just use the the average returns of the strategy. And don't forget, we actually need to use the unrealized returns. If you calculate the Sharpe ratio with the realized returns, it's just going to be complete garbage. So we need to go unrealized, and then we divide this by the standard deviation of the unrealized returns. And in order to annualize it, we need to multiply it by the square root of the number of trading days in a year, which is 252. But sometimes I'm just lazy, and I actually just multiply it by 16, which is the square root of 256. So sometimes that's just easier to do. And, you know, the trading days per year changes. And, you know, backtesting is definitely not an exact science. So if you use this number or that number, it doesn't actually make that much difference. And so we run this and we can see, well, our Sharpe ratio is 0.4. That is not particularly impressive. That's not a great strategy to use. I mean, when you're in a backtest and you have a strategy like this, you should get at least a Sharpe ratio of 1. Otherwise, it's not fantastic. But again, I'm not choosing this strategy today to produce a fantastic strategy. I rather want to show you how to use a backtest and how to run a backtest and what the process is like. Okay, now, can we improve the strategy? Well, if we think about it, equities most of the time are going up. Unlike other more symmetric asset classes such as Forex or commodity futures, equities in general tend to have a positive upward positive drift. So maybe we should say, well, actually, why don't we just run a long only strategy, and we only go into a long position when we use the moving average crossover. And I show you next how to do this, because this is sometimes quite handy, and you can also see the changes that need to be made to the strategy just to make it a long only strategy. And the first thing is, when we enter a short, we actually don't want to enter the short, so we say in pos equals 0. So we're not in a position. And then the other things we need to do is to basically not go or not collect the entries. So we can just comment this out. If we comment this out, it's just we can do block comments in Python notebooks, which is control slash. And so once we comment this out, we're actually not any longer running short trades. We're only run long only trades. So let's do this. And here we go. This is our long only trade. Looks a bit better, right? So let's just see how our Sharpe ratio improved when we run this long only trade. All right, it went from 0.4 to 0.73. And this is somehow expected because, you know, we're running a long only strategy on an asset which over time mostly went up. And so the short trades are not particularly good. And in fact, from my own experience with trading equities, I always found that short equity strategies or short side or trading equities on the short sides is generally very much a losing game. It's very difficult to run algorithmic strategies for equities on the short side unless you do really high frequency trading. But if you just trade normally and you do sort of more investing style trading, then short equities is a really, really difficult one. All right, so we've got our long only strategy, and let's just calculate a few more metrics. So one of the metrics that I like using is profit per trade. So that's we call this PPT, and that's just simply the average of the realized P&Ls. So we calculate this here, and then let's just see what this gives us. So our profit per trade for this strategy is actually 14.7%, which is a pretty high profit. And, you know, so we don't normally, when we have a 14% profit, we don't normally have to worry about trading costs. But if we have, you know, profits of just maybe 20 or 30 or 50 basis points, then trading costs will come in a lot more. And so what I'm going to do next is I show you how to incorporate trading costs. And there's a lot that can be said about trading costs, but for now, I just want to show you how to incorporate commissions. So let's say we every time we make a trade, we have perhaps commissions of 10 basis points or 0.1%. So what we can do is we can say commission equals 0.001, which is effectively 10 basis points. And so now when we calculate our profits here, all we have to do is do minus 0.00, and then we need 2 because we have an entry and an exit. Okay, so we need to calculate, we need to account for the commissions twice, for the entry and for the exit. And so if we run this, again, we will see a bit of a discrepancy between those two strategies, but we can't really see the difference because it will be a bit different anyway. So if we wanted to see really difference between commissions and no commissions, we would have to go back to calculating dollar values in order to get this right. Now, another question is, how would we incorporate commissions into the unrealized P&L? And so that's a little bit more tricky, but what it basically involves is to just add it in when it happens. So what we need to do here is, as soon as a trade happens, in this case, so here, we just say unrealized, and then we take the last value of unrealized and we say minus equals commission, right? And actually we do the same here. So remember, the long entry is the short exit. So we need to actually account for these commissions here. Even though we are long only, we have to include this twice. And so if we run this, then you can see we take account of the commissions, but unfortunately we can't really see this here very well because we're working with dollar values, and you always see the slight discrepancy between the two lines. But anyway, this is how you account for commissions. For realized commissions, you just include them here, and for unrealized, you just include them here. You just change the last entry of the unrealized whenever a trading event happens. Okay. Now, another thing that is really interesting to look at is how long do we hold a trade for? So hold times quite often can make a big difference. So for example, if we have a backtest and our trades or the hold times are like 5 years, we may as well go for long only. We don't really need to run a trading strategy for this. So we want reasonable hold times on average. And how do we calculate them? We can, for example, do this hold time. So we create another list, hold times. And then whenever we enter a trade, so for example, we entered the long trade here, we say start equals, and then we can do it both. We can do it two ways. We can either use the dates or the indices. So in this case, I could say, for example, spy.index of I, and then when we exit, I could do something like hold times dot append spy dot index of I minus start. And now that gives us a datetime object, but really what we actually want is more of a simple number of this in days. So luckily in pandas, you can just simply put a bracket around this and then do dot days, and you get actually the days. And so if you run this and then we look at our hold times, we get a list of days, hold times. And you can see here, we get all the different hold times. And then we can calculate the average hold time. And here we go. Our average hold time is 116 days. So it's about, 4 months or so, for 3 months, 4 months, in 3.5 months, I guess, for our average hold time. And yeah, that's kind of expected for a strategy like this.